Hello and welcome to CS 303. Today we'll be starting with chapter number 2. So chapter number 1 was introduction. We have already covered that. So we briefly defined in chapter number 1 we briefly defined what an OS is, what are some of its goals, objectives, duties. We did a brief overview of computer architecture because now we know that the OS interacts very heavily with the underlying hardware, right? So, how instructions are executed, loads and stores, and all those things, will definitely help us. So we did that, and then we looked at various kinds of computing environments: single CPU, multiple CPU, cluster, distributed, real time, mobile, so on and so forth. So now what we'll do is talk a bit about operating system structures. So this is chapter number 2, lecture 1, operating system structures. So since we already covered or we already spent about 30 minutes finishing up chapter number 1, so today we'll just cover a small number of slides worth about 20 minutes. Okay. So operating system structures, chapter 2, lecture 1. Now I am on slide number 2. The title of the slide is chapter 2 outline. Okay. So slide number 2, chapter 2 outline. So here we sort of give an overview or a blueprint or a roadmap of what this chapter is all about. Okay. So here we will look at an operating system from three different views, three different point of views. Okay. So one view will be from the user side. So which means how do common users, right, not computer scientists, not scientists like you, students like you. So from an ordinary users or from a common users point of view, how do they look at the operating system? Next view is a programmer's view, right? So you could definitely fall under this. If you get a job in an OS company like Microsoft or Apple, right, or Google, of course. So the second view is from a programmer's point of view. So when you're creating modules, when you're writing software for the operating system, how do you view the OS, right? And the third view is from a system designer's point of view. So again, some of you will be system designers also. So here the idea is how do you design or how do you structure the OS, right? So we've established the fact that an operating system is a huge piece of software. So one person or even one team can't totally design it, right? So what you need to do is when you're operating or when you're looking at such a huge piece of software, from software engineering, what we learn is we can divide that software into certain parts, certain chunks, certain pieces, certain layers, right? So and then each part can be looked at separately. So just taking a large problem, dividing it into smaller problems which are easier to solve and manage. Okay. So if you're designing an OS, then from your point of view, how does the OS look like? So three different points of view: user view, ordinary users, user views, not people familiar with computer science, computer programmers view, and then finally system designers view. So from these three views, these three angles, we'll be looking at an operating system in this chapter. Okay. So definitely from a user's point of view, we'll look at the kind of services that an OS provides. And another aspect which is very important is the user interface, because using the user interface, the user can interact with the OS, right? Whether it's launching a program, stopping a program, moving files around, deleting files, and so on. All that happens through the UI or user interface. From a programmer's point of view, the one key aspect is system calls, right? So kind of functions which in turn call OS services. So we'll discuss system calls. And then from a system designer's point of view, how can we, or how are operating systems designed and what are their structures? So here, from a historical perspective, also we look at, how different operating systems are structured, starting with DOS and then, moving to Linux, Windows, and even mobile phone operating systems. So how are they designed? What are some of the design principles, and what exactly is the structure of an operating system? And finally, we'll wind up by talking about operating system monitoring, debugging, or troubleshooting. So how can I monitor the OS performance? How can I debug an OS, right? How can I troubleshoot if something is going wrong? So in short, this is the outline for chapter number 2. Right, so now I am on slide 3. So now we talk about objectives of chapter 2. So slide number 3, objectives of chapter number 2. So to describe the services an operating system provides to users, to processes or programs, and to other systems. So this is the user view. To discuss system calls, this is the programmer's view. To discuss various ways of structuring an operating system. This is from an OS designer point of view. So we will discuss several designs. Apply tools for monitoring operating system performance. So maybe you want to bill users if you want to use an external high performance computing facility. Depending on how much CPU or memory you have used, you may get a bill. To keep track of usage, how much each process is using, for bookkeeping, and for diagnosing problems. So if you see that you have a small number of programs running, and yet your CPU utilization is very high, so maybe there's a bug, maybe there's a virus, something is going on. So using these different kind of tools, which we'll study, you can monitor the OS performance. Okay. So when we say performance, we mean that generally how your programs are using the CPU, what is their CPU usage, how they're using your main memory, their memory usage patterns, how they're using their disk usage patterns, how they're using the network, internet, and so on, right? So essentially the usage patterns for all of these will give us the performance of the processes and of the OS in general. Okay. So these are the various learning objectives, various things that we will learn once we finish chapter 2. Okay. Okay, so now I am on slide number 4. Title is a view of operating system services, user point of view. Right. So OS services from user point of view. So here we see a picture in which we've got different layers. At the bottom layer, of course, we have our hardware, right? Our CPU, memory, IO devices, so on. And then above that, we've got our operating system, right? And you can see within the operating system, these services which are provided, right? So from the services, you can see program execution, IO operation, file systems, communication, resource allocation, accounting, error detection, protection, and security. On top, you have the system calls, and then above that, you have the user interfaces, command line, batch, graphical user interface. So we'll talk about all of these. And at the very top, you have users and other system programs. Okay. So essentially what happens is, the users, they using the user interface, they can do different tasks like opening up an application. Let's say opening up Chrome, opening up Microsoft Word, and so on. So using the user interface, I'll double click it, and then what that will do is that will generate a appropriate system call to launch the application. Okay. So what the system call will do is, on the user behalf, it will execute some operating system code, right? So for each operating system service, we have a system call, right? So program execution is an OS service. So when why do we want to open the program? We want to open the program for executing it. So that, when we double click it, then that will lead to an execution of a system call. System call will be executed by the kernel in kernel mode on the behalf of the user, right? To get that OS service. Okay. So you can see that all these services are within the operating system layer. Okay. And then lowest we have hardware, right? So generally, that is how things operate. A user using the user interface interacts with the operating system, uses its services, and for each service we have a specific kind of system call, which is launched and executed by the operating system kernel on behalf of the user, right? And of course, it will be directly accessing the hardware resources. So essentially, the OS does all of these operations on behalf of the user. So the user's life is extremely simple. Okay. So we have different services here, and we'll talk a bit about them now. Okay, now I am on slide number 5, operating system services. So slide number 5, operating system services. So from chapter 1, operating systems, we learned that operating systems provide an environment within which programs can be executed, right? Just as a background. And OS can be viewed from various angles. So one angle is from the point of view of the services that it provides, right? So one set of operating system services provides functions that are helpful to the user. Okay. So user interface. So how are users interacting with the OS, right, to get their job done. So there are various options. One is a command line interface, which you may have seen, when executing C programs. We'll discuss it soon. One is a graphical user interface, so using windows, files, and folders, right, icons. One is a batch interface. So batch interface, you have minimal interaction, in which you have some job to run, and you just send the job and then just get back the result. So this generally happens in, let's say, high performance computing systems. So we won't talk that much about that. We'll focus most of our attention on command line, CLI, and graphical user interface, GUI. So that's one service US has to provide, a user interface through which users can interact with the OS. Program execution, right? Definitely that service has to be provided, because the main goal of an OS is to execute programs. So system must be able to load a program into memory. So from disk to load it into memory and to run that program, which means the CPU executes the program's instructions to end the execution when it terminates, either normally or abnormally indicating error. Right? So maybe the program was trying to access some piece of memory which it was not supposed to, and which led to the program being aborted, right, before it could finish. Okay. Another service is I/O operations. So running program may require I/O, which may involve a file or an I/O device. And do recall from the earlier chapter that for the sake of security, no direct control of I/O devices is given to the user. So any I/O interaction has to pass through the operating system, which will verify it and regulate it. Okay, so that's a third service, I/O operations. Okay. So slide number 6, operating system services continue. So some more OS services are useful to the user, right? File system. Programs need to read and write files and directories, create and delete files and directories, search among them, list the file information, what kind of files you have, what are the sizes, permission management, which file can be handled by which user. To handle a root file, you need administrator access, right? Hence, the OS needs to support a file system, right? So, organization of files and directories, and then various operations to be performed on them. So we use all of these a lot. We work with files every day. So some kind of system for managing these files and directories needs to be there. It is provided by the OS as a service. Communications, of course, very important. Processes may exchange information either on the same computer or between computers over the network using the internet. So communication may be via shared memory or through message passing. Network packets are moved by the operating system. So these days, all computers are connected, which was not the case many years ago. Before the internet was invented, machines were standalone, and it was not possible, for one machine to communicate with the other. Of course, all that has changed now. All machines are connected using the internet network. So the OS needs to provide communication service. Error detection. OS needs to be constantly aware of possible errors which may occur in the CPU, in memory, in IO devices, and user programs. Okay. For each type of error, the OS should take appropriate action. Action may be sometimes to halt the process or sometimes to reboot the system. Right. So some example errors: you're looking for a file, but the file cannot be located. You're trying to access a file, access is denied. Disk is full, so you cannot put any more data on it. Stack overflow. Stack is used for storing function calls. So let's say you have a very deep recursion, in which you have an extremely large number of recursive function calls, which eventually will overflow the stack. So you will not be able to store any more function calls. Your competition will not be able to execute correctly. So you can have various kinds of errors. Error in the CPU, right? Some either CPU hardware error, using which some register is not working properly, because of which calculations cannot be done. Error in memory, a process trying to access the memory area of another process. Error in IO devices, right? Some IO device hard disk corrupted. Error in user program, some bug there. So there can be many kinds of errors, and one of the services an OS needs to provide is that of error detection. So in each case, error has to be detected by the OS and appropriate action needs to be taken. Now I am on slide 7, operating system services continued. Right? So another set of OS functions exists for ensuring the efficient operation of the system itself. So now we're not talking that much from the user point of view, but from the system side now. Okay, so what are some of those services? Resource allocation. So we know OS, one of its major goals is it has to allocate resources fairly and efficiently among many programs. Right? So resource allocation. When multiple users or multiple jobs are running concurrently at the same time, resources must be allocated to each and every of those jobs. CPU time, main memory, file storage, IO devices. Scheduling algorithms in place for allocating CPU time. So, one of the services here is to allocate these resources to the programs. So, how they are allocated, there are various algorithms which we'll be covering, as we move on in the course. Accounting, to keep track of which users use how much and what kinds of computer resources. So we have a task manager in Windows, which we can use for that. We have an activity monitor in Apple OS. We have the top utility in Linux. So no matter what the OS, some utility or the other exists. And in Linux, we have many advanced tools as well. We'll look at some of them. So we may need to do accounting for billing purposes, to check for quota, or to improve some aspects of the OS by reconfiguring the system. So maybe we are seeing that the CPU usage is exceptionally high. Maybe we are seeing the disk usage is exceptionally high, or the main memory usage is exceptionally high. So maybe it could be a bug, a virus, or maybe we just need more memory. So we can diagnose and we can reconfigure, take appropriate action, right? So we can improve protection and security. Another service. Owners of information stored in a multi-user or network computer system may want to control use of that information. Concurrent processes should not interfere with each other. Right? Protection involves ensuring that all access to system resources is controlled. Right? So we have some rules regarding who can access what resources. And security of the system from outsiders requires user authentication, extends to defending external IO devices from invalid access attempts. So we can have user access, user authentication, where you provide a username and password, something very simple. For some of the key OS pieces of code, we can have only root access, only the admin can access them. The users cannot. Of course, the assumption is that the admin or the root user is not compromised. We can have a antivirus program which has its own database and it continuously scans for suspect files. We can have a firewall for net for attacks that take place through the internet. So all these services need to be provided by the OS and need to be supported by the OS. Okay.